What's up, everyone? This is the circuits review video for your upcoming circuits test. Okay, so majority of it will be multiple choice. Make sure you also be prepared for a short answer question, which means you gotta show your calculation work with units. And so there's gonna be a variety of topics involved here. Some of it will include series versus parallel circuits, current, voltage, and resistance, and how they change between the two types of circuits. And what else? Electrical power. Whoa, there we go. Electrical power, Ohm's law, and that's essentially the main gist of it. So let's begin. There are 33 questions, I believe, on this review question packet. You guys should go check on Pupil Path for the PDF document if you want to download for your own personal copy. If not, then you could just follow along with this video and have out a piece of paper if you want to go through it on your own. Alright, so let's start with number 1. Please excuse the voice, I am still recovering from my cold. Okay. Electric circuit consists of a variable resistor connected to a source of constant potential difference, so that means our voltage is the same. If the resistance of the resistor is doubled, the current through the resistor is what? Alright, so we're focusing here on resistance and current. If you think back to Ohm's law, resistance and current have an inverse relationship. That means if we increase our resistance through the circuit, our current I should go down. Alright. Looking at Ohm's law, V equals IR. Do we see any squares here? No. So that means the factor in which they change should still be about the same. Okay? So if we're keeping V constant, if R goes up, current should go down. It's an inverse effect, so if R is doubled to R, this should translate to half of our current. Choice A. Number 2, in a simple electric circuit, a 24 ohm resistor is connected across a 6-volt battery. What is the current in the circuit? Okay. Oops. Okay. 24 ohms is our R. We have a voltage of 6 volts. We're looking for I. Ohm's law is the equation we need. Please note my handwriting. I am not using my regular stylus. 6 divided by 24 gets you 0.25 amps. Choice B. Hey, look, that's a familiar question. Should have noticed that in the IA, ladies and gents. Number 3. What is the minimum equipment needed to determine the power dissipated in a resistor of unknown value? Alright. Alright, power. There are different ways to calculate power. P equals IV, V squared over R, or I square R. Alright. So they also mention resistor of unknown value. That means we don't know what R is. But we can use voltmeters and ammeters to get what V and I are. So we could still figure out how to find power without even using resistance. So here, P equals IV. That means we need a voltmeter for V and an ammeter for I. So that's choice C. We could do that. You don't need a stopwatch, to be honest. Even though power is the rate of energy, you don't really know how to calculate energy without power. Alright, next. 4. Let's pick a different color. Let's go with blue. What is the current in a 100 ohm resistor connected to a 0.4 volt source of potential difference? Alright, V equals IR once again. Point 4 divided by 100 gets you this. But look here. If you notice, our units here are milliamps, but the answer we got is in amps. So in order to convert to milliamps, you want to move it over to 3 places. 1, 2, 3 this way, and you get 4.0 milliamps. Alright, choice D, everybody. Okay, so number 5 here has a bunch of graphs. If you think back to the packet, what type of graph is shown here between voltage, current, and resistance? Okay, so it says here we have a graph of current and potential difference. That means we want our current Y. If we're going to set this into a graph like Y equals mx plus b, am I spewing too much stuff? Well, go with it, guys. Okay, current is going to be our Y, because if you notice here, it's on the Y-axis. Not to say that A is a choice, that just happens to be right there. Alright, so we're going to bring Y, make I by itself. So we're going to divide here by R. So we get V over R is equal to I. Potential difference, V, is our X. If you notice, if we convert this, it looks like kind of like Y is equal to mx right there. Okay? And what we see here is a pretty linear line. And what do we know here? The only one that shows a linear slope is choice D. I also mentioned this to you guys. You should have copied it down in your packet. If you didn't, shame on you.
Slackers.
That wasn't me, but let's go with it. But anyway, if you notice the graph here for choice D, it's a linear line. What do we know about the relationship between current and potential difference? When V goes up, I also goes up. It's the same as adding more batteries, which results in higher current. Makes sense, right? Yeah? Yeah. Okay, so number 6 is kind of tricky. Let's see here. We have a constant V applied across a variable resistor. Variable meaning it's not a constant resistance, so we're going to see some curviness to our graph. Hint, hint, curvy. Okay, which graph best represents the relationship between the resistance of the variable resistor and the current running through it? Alright, so resistance, if resistance goes up, what happens to our current? It should go down. So we're seeing a curvy graph with a decreasing slope. Let's look at our choices here. A, B, C, or D. B is out. C is out. So is D. All of these are increasing. The only one that fits is A. There we go. Number 7. 2 ohm resistor and 4 ohm resistor are connected in series with a 12 volt battery. If the current through the 2 ohm resistor is 2 amps, the current through the 4 ohm resistor is... Alright, for some of you, maybe drawing the circuit might help. Okay, we got 2 resistors in series with each other. 2 ohms, 4 ohms. Hint, hint, we're in series. What do we know about current in series? Current in series remains the same. So if current over here is 2 amps, then the current over here is also 2 amps, alright? So our choice here is B. Alright, next. Number 8. The diagram below represents a circuit consisting of two resistors connected to a source of potential difference. Hint, hint, we have here a series circuit, and it's looking for the current through the 20 ohm resistor. Alright, how the heck are we going to figure this out? Okay. Please note we have a series circuit. The current that goes through the 20 ohm resistor is going to be the same as the current that goes through the 10 ohm resistor. If you jump right ahead into V equals IR, that is the wrong move. What you want to do is find the equivalent resistance between both of these. Since we're in series, we just add them up. And we get 30 ohms, okay? That is now the equivalent resistance of the entire circuit. Now we can jump into V equals IR because the current that runs through the whole circuit is the same as throughout each part of the circuit. 120 V is equal to I times 30 ohms. I is now equal to 4 amps. Choice D. Let's double check with my key. Yep, it is 4 amps. Okie dokie. Next. Number 9, circuit A has 4 3 ohm resistors connected in series with a 24 volt battery, and circuit B has 2 3 ohm resistors connected in series with a 24 volt battery compared to the total potential, blah 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 blah. Okay, let's draw out circuit A. Got 4 resistors in series with each other, and this is B. Just 2 resistors in series. Okay. Oh wait, we didn't really need to do this. It says compared to the total potential drop, the total potential drop across B is the same because they're having the same battery, the same voltage runs through each of these circuits, so the total potential drop is still the same. Please note this is referring to V, not I or nor R. Okay? Number 10. 3 ohm resistor, 6 ohm resistor are connected in series in an operating electric circuit. If the current through the 3 ohm resistor is 4 amps, what is the potential current difference across the 6 ohm resistor? Alright. Okay, connected in series, so series circuit has same current I. Alright. So the I that goes through the 6 ohm resistor will still be 4 amps, and the resistance we're worried about is 6 ohms. We're looking for V. V equals IR equals to 4 times 6, and we get 24 volts. Alright, choice D. Number 11. 3 ohm resistor and a 6 ohm resistor are connected in parallel across a 9 volt battery. Which statement best compares the potential difference across each resistor? So here we're dealing with parallel circuit. Here the current does not stay the same, rather it's the same voltage between the branches. So no matter how many branches we have, the same voltage is going to be running through each branch. Alright? So same voltage running through here. Same V. So if we look at our choices, the answer that follows that is choice A, the same. Okay, number 12. There's a lot of space on this page. Okay. Which has the smallest equivalent resistance? So if I were you, I would just go through each of these one by one. But here's another hint here. Series circuits increases that REQ, whereas parallel circuits it decreases it. So if we're looking for smaller ones, we're going to look for parallel circuits. Another cool thing is that parallel circuits, more branches, mean less resistance. So between A and C, C is our answer because there are more branches to be divided up, means less resistance, more pathways for the current to flow through. All right, number 13. 3 resistors, 4, 6, and 8 are connected in parallel electric circuit. The equivalent resistance is, all right, parallel. That means we're dealing with this. We're adding up the fractions. If you want to plug and chug into the calculator, be my guest. This is how it would look like in the calculator. Just remember, you're looking at the inverse button right above the 7. So you would do this. Alright. Or if you want to do it the fraction way, follow along. Common denominator between 4, 6, and 8 will be 24. Alright. 6 plus 4 over 24 plus 3 over 24 equals 6 plus 4 plus 3 is 13 over 24. And that's equal to 1 over REQ. We need to flip that. So REQ is equal to 24 divided by 13. That is a little less than 2. So it's going to be a high 1. And if you look at here, less than 4. Okay? If you also think back, and when you connect things in parallel, the resistance will always be smaller than the smallest resistance value here. Right? 4 is the smallest resistor value here, so the equivalent resistance will always be smaller than that in only a parallel circuit. Okay. Alright, this will be the last page for this part of the video. The other half of the review video will be questions 18 to 33. Okay, so let's start with 14. In which circuit would current flow through resistor 1 but not through resistor 2 while switch S is open? So open meaning it's depicted exactly in the images, it's not connecting. Alright, so if we look at each of our images, that means we want current flowing through R1 but not through R2. We could already cross off C because if you disconnect the switch, current will not flow through the entire thing. That means we want in parallel. Alright? If you look at each of these images, can't be choice B because that switch blocks off both of them. Can't be switch D because it blocks off D, so the only one is choice A. Because if you take either direction, that means that switch will essentially cut off that branch of the circuit, whereas R1 is left intact. Okay, number 15. Another familiar question from the IA. Okay, I'm going to put a dot here right in the middle because that's our junction. So the total current that goes in, total I in, is equal to total I out. So pay attention to the direction of the arrows. 5 and 7 point inward. And it has to equal 3 plus whatever is missing. So 9 is equal to X. That has to be the one that flows out through here. So 9 amps. Alright. Where should an ammeter be located to correctly measure the total current? Okay, and where should a voltmeter be located to correctly measure the total voltage? Alright. voltmeters must be parallel. Total V across the battery. Alright, so if you look at each of these choices, it has to be 4. Position 4 for the voltmeter. The ammeter, A, must be in series. If you want total current, has to be next to battery. Okay? The only one that fits that is position 1. If we look at our choices, the answer that fits that is choice A, number 17. To increase the brightness of a desk lamp, a student replaces the 50-watt incandescent light bulb with a 100-watt incandescent light bulb. Compared to the 50-watt light bulb, the 100-watt light bulb has... Okay, so here's reusing resistance and current here. P is equal to I squared R. Alright, so what is happening here? If you think back to some of our labs, when we're increasing brightness, that means we're adding more current. And as a result, when you add more current, what happens is that resistance follows as a result, a decrease in resistance. So here, choice A is the only one that fits that bill.